The first thing that's important that you notice on this review sheet is at the top it says no calculator. You will be allowed to use a calculator if the calculator does not have the buttons sine, cosine, and tangent on it. So if you have a calculator that just adds, subtracts, multiplies, and divides, you may use that. You may not use a cell phone or iPod calculator. But if you have a small, what we call 4-function calculator that's just good for straight arithmetic, you can use that. But no calculators with trig buttons. Don't stress about the arithmetic. If you show me your work and I can see you knew what you were supposed to be doing and something got added or subtracted wrong, it's not a big deal. That's not what I'm testing on. I, of course, think it's an important skill, but that's not really what I'm testing on. So just make sure that you show me your work so that I know that you knew what you were supposed to be doing. The first type of question says to be able to draw angles given in degrees in standard position. And then the second one is being able to find coterminal angles in degrees. In our lesson, we did them both in radians. On the quiz, it'll just be in degrees. So let's look at some examples of those. So if I give you an angle, like 170 degrees, and I want you to graph that. We graph on XY axes. Where do we start our angle?
0.
Where is 0? On the right side. So we start on the right side. And which direction do I go?
You start counterclockwise.
Counterclockwise. And if I go 170 degrees counterclockwise from that 0 line, where will it end up? Just short of the 180. How far short? 10 degrees. Your graphs of angles must have a few things there. You have to have your x and y axis. You have to have the arc that shows me what direction you drew the angle. And you have to have that little number next to your closest x-axis that tells me how big you intended that angle to be. That number is called our reference angle. It would be true to put the 80 on the other side and say that it was 80 past the 90, but that will not earn you full credit because we need to always be considering its relationship with the horizontal x-axis. So we always want to make sure we're putting our reference angle in the correct location. Now, if we think about coterminal angles, we said coterminal angles, breaking it down. Co means together with, terminal means ending, so they're angles that end with each other or end in the same place. Those happen once every circle. How big is a circle? 360. So how do we find our coterminal angles? Add and subtract 360. And just as on the assignment, you will need a positive and a negative solution. So if I take 170 and I add to that 360, and once again, if you just show me what you're trying to do, if you don't have a calculator and you're worried about adding wrong, just show me what you're trying to do, and then I'll know you were trying to do the right thing and something went wrong with your adding. I add it up and get 13, and 1 and 1 and 3 makes 5, so 530 is a positive answer. To find a negative answer, I would need to subtract 170 minus 360. I don't know about you, I always found subtracting when it was kind of bottom heavy like this to be confusing, when the number on the bottom is bigger than the number on the top. So here's a trick. Just do it backwards. So I'm going to do 360 minus 170 because that makes more sense to me. So 0 minus 0 is 0. I need to borrow here for the 6, so then I get 190. And then just make your answer negative. And that'll be the right answer. Okay? So if you're confused by subtracting bottom heavy like I am, then just flip it upside down and then just make your answer negative. Works just the same. Okay. Let's do another example. Let's say our starting angle is negative 110. What's different about graphing negative angles? They go the opposite direction. So where will 110 land then?
Just 60 before the 180. 70, sorry.
All right, so I'm going to come around this way, and that would be 70 before the 180. It is also true that it is 20 past the 90 mark, but we always want to be comparing to the 180 or the 360 line. Now, coterminal angles. If I add 360 to this, 360 plus a negative 110 is really subtracting. So that would be 250. And if I do negative 110 minus 360, since they're both negative, that's really doing what? Adding them. So I get negative 470. By the way, you can see some of these coterminal angles graphically, if that helps you. So on the previous one, if that subtraction part was difficult to come up with that negative 190, just look at your picture and think about what a negative angle would do. The negative angle goes in the other direction, and it's half a circle of 180 and an extra 10. So that makes 190. So you can see these angles graphically as well. Or, on this last one, I could see that positive angle of 250 by going around in the positive direction. 180 and 70 makes 250. Okay, so you can see your coterminal angles as well. One more example of this type. If my starting angle is 400, what do I do to graph this? Start at 0, and then
you go around twice. Well, not twice, but you go around once, which is 360, and then you go around 40, which is in between.
All right, so we go around once to cover 360, and then we go an additional 40 to make it to 400. So if your angle is bigger than a full circle, we just draw that spiral in there to show that we have more than one full circle. Our graph actually shows us our positive coterminal angle. What's a positive coterminal angle with 400?
40.
Just a plane 40. A plane 40 would be just going 40 instead of going all the way around once and then going 40. How would I find a negative coterminal angle?
You do it twice. You subtract 360 twice because one time it's positive and one time it's a negative.
We subtract twice, so we get that 40, and then we can subtract from that 40 to get negative 320. Again, graphically, we can picture this if we imagine starting at our 0 line and going around backwards. We would have gone 320 degrees in the backward section, ending 40 away from a full circle. Okay. Questions on graphing or coterminal angles? Yes? You could add 360 to 400, and that would give you a positive solution, and that would be fine. But that 40 is also an appropriate positive solution as well. So that would work. That would count as our positive answer. We need one positive and one negative. So we just add and subtract as many times as it takes to get there. It'll say draw the angle and give a positive and negative coterminal angle. The next part of the review sheet says that we need to be able to convert between degrees and radians. What was our conversion? Just like 12 inches is 1 foot, how do we move back and forth between degrees and radians? 180 in pi. So 180 in degrees is equal to pi in radians. And we're going to set it up as a fraction to do our conversions. So if we were given 60 degrees, make whatever you're given into a fraction, so I can put it over 1 if it's not a fraction. Multiply that by 180 in pi, set up as a fraction. And the way you can tell which way to set it up is put the given thing on the bottom so that they will cancel each other out. And so the other part goes on the top. Then we need to reduce. How many times does 60 go into 180? 3. So that leaves us with a denominator of 3. Let's say we were given radians instead. If I was given 2 pi over 3, it already is a fraction, so I don't have to make it into a fraction. So now I'm going to multiply it, putting pi on the bottom with 180 on the top. So the pi's will cancel. And now we have two different things to do. We need to multiply by a 2 and divide by a 3. And it doesn't matter what you do first. You just do kind of whatever feels more comfortable to you. So you could do 2 times 180 and then divide that by 3. I personally like dividing first because that makes numbers get smaller instead of bigger. So how many times does 3 go into 180? 60. And then I've got 2 times 60 left to take care of, which is 120. Okay, and once again with this arithmetic, if you don't have a little calculator to use, just make sure you show me what you're trying to do, and I'll know that you knew what you were supposed to do and arithmetic went wrong. Questions on converting?
What lessons?
That was, so far, everything has been in the first trig lesson. We did 3 trig lessons. That was all in the first one. It was called angles and radian measures. The next bullet point says be able to evaluate trig functions for special angles using our unit circle and our 30, 60, 90, 45, 45, 90s. The bummer of Monday quizzes is that they often get forgotten about over the weekend. So I urge you to not forget about this because there's a lot of stuff you have to have memorized for this quiz. You have to know our conversion, what 80 equals pi. You have to know your unit circle and be able to draw that. You have to know your 30, 60, 90, and 45, 45, 90, and you have to know SOHCAHTOA. So there's a lot of stuff to make sure that you know. So please remember this and study for it so you can be prepared to do well on Monday and not come in surprised. Let's do some examples. So solving for trig of special angles, you will be given a trig function like sine, and you will be given an angle like 135. First step is to graph the angle. So when I graph 135, starting at my 0 line, where does it land?
50, no, 45.
45 before the 180. It must always be a reference angle of 30, 60, or 45 if we need to evaluate trig on it because it's the only angles that we know stuff about. Close up that angle with the x-axis, always with the x-axis. You should have a special triangle at this point, either 30, 60, 90 or 45, 45, 90. This is 45, 45, 90. Label the sides. What are the sides of the 45, 45, 90?
1 and 2.
1, 1 and square root of 2. Then we need to consider any of these sides may be negative according to their direction. So what about any negative sides here?
The one on the bottom.
The bottom one is left of the origin. So right and left for the horizontal segment tells us positive or negative. The vertical segment is up from the center, so it's positive. Down from the center would be negative. Hypotenuse is always positive no matter what direction it looks like it's going. So now that our triangle is all labeled, we're ready to think about SOHCAHTOA. What's SOHCAHTOA for sine? Opposite over hypotenuse. According to that reference angle, what is the opposite?
1.
1. And the hypotenuse? Square root of 2. So that's our final answer for that one. Let's say we had the cosine of 5 pi over 6. We split each half of the circle into 6 pieces. When you graph in radians, you take what the denominator is and cut each half into that many pieces. So 12 pieces all around, 6 pieces on top, 6 pieces on bottom. And then how do we figure out where our angle is? So go 5 pieces around, and that gives me my angle here. How big is that angle?
40, 45.
30. It was 180, half of a circle divided into 6 pieces. 1 divided by 6 is 30. 1 across from the 30. What are the other sides of the 30, 60, 90?
A square root of 3.
A square root of 3 and a 2. What's the hypotenuse?
Square root.
The 2. Be very careful when you're working on memorizing this pattern because students often write it backwards. Okay, 2 is the hypotenuse. Square root of 3 goes across from 60. What about negative sides here? Square root of 3 is negative because that's a left horizontal. 1 is positive because it's an up vertical. So now we're ready to SOHCAHTOA. What's SOHCAHTOA for cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. What is adjacent?
Negative square root of 3.
And hypotenuse?
2.
Look at one more of this type. Let's say we're going to do the tangent of 90. Begin by graphing. 90 degrees would get us to that vertical angle. We can't draw a triangle when we land right on one of the lines. When you land in a space, you can make a triangle out of it. If you land right on one of your axis lines, a triangle doesn't work. What do we do instead?
You do the negative 1, 1, 0.
We do our unit circle points. What would this point be on the unit circle?
0, 1.
Over 0, up 1. X comma y, how far you go over, comma how far you go up. So that point at the 90 line would be over 0 and up 1 unit. How does that point help us find trig?
Oh,
Does
you
the
do the.
adjacent
Is
is
this
the
inverse trig?
You do the sine and cosine thing.
sine
In what order?
alphabetical.
Alphabetical.
Alphabetical. So it's cosine, sine. So if you were asked for the cosine of 90, it would be the first part of that point, 0. If you were asked for the sine of 90, it would be the second part of that point, 1. But we are asked for the tangent of that point. What is tangent equal to? Opposite of our adjacent if we have a triangle, but we don't have a triangle. So what else is tangent equal to? Sine over cosine. So lots of stuff to memorize here with being able to use our unit circle appropriately.
1 over 0.
So the sine is 1. The cosine is 0. What is 1 over 0? You can't divide by 0, so we say that solution is undefined. Questions on right triangle trig or unit circle?
Can you do another one where you have to use the 0?
Where we need to use the circle? Sure. Let's try the cosine of 270. So we begin by graphing it. Where's 270?
It's right on that thing,
Which one?
the bottom one.
The bottom one. So 270 is 3 90s around, so we land on the bottom line. What is that point on the unit circle?
0, negative 1.
Over 0, down 1. And the point, no matter which one of those lines it is on, is represented in the same order alphabetically, cosine, comma, sine. So what is the cosine value of that point?
0.
0. Cosine is the first part of the point. Okay? The last thing on the review sheet says to be able to do inverse trig. Inverse trig is what we studied in our last lesson. You will still be given a trig type like sine, but then it will have that little negative 1 on it. That little negative 1 says that we're doing the inverse here or doing the problem backwards. The answer to an inverse trig question is an angle. The directions will also give you a hint about that because they're going to ask for your answer in both radians and degrees. Radians and degrees are angle things, so we know our answer should be an angle. And then you'll be given a fraction, something like 1 over square root of 2. And we want to know the angle that this would be true for. What is SOHCAHTOA for sine?
Opposite over hypotenuse.
Opposite over hypotenuse. Then we line up that fraction. That 1 needs to be the opposite, and 2 needs to be the or square root of 2 needs to be the hypotenuse. Where do we have a square root of 2?
45.
The 45, 45, 90. You are never allowed to choose 90 in a triangle because 90's opposite is the hypotenuse. So 90 has some problems. So in the 45, 45, 90, the only other option is 45. Since we need to give our answer in both degrees and radians, how many times does 45 go into 180? 4 times. So pi over 4.
Is that the homework yesterday?
Let's try inverse cosine of square root of 3 over 2. What is SOHCAHTOA for cosine? Adjacent over hypotenuse. Then we line up the pieces of that fraction. Square root of 3 needs to be adjacent. 2 needs to be hypotenuse. Which triangle are we talking about? 30, 60, 90 has a hypotenuse of 2 and a square root of 3 in it. This question says we want to be adjacent to the square root of 3, so right next to the square root of 3 is which angle?
30.
The 30. 30 goes into 180 how many times? 6.
You explain how we got the 30 again.
We know that cosine is adjacent, so we know we're looking for an adjacent angle to the square root of 3. So we look at the square root of 3 and say what's adjacent or right next to it. So the 30 is right next to it. And let's try inverse tangent of 1. It's not a fraction. It's easiest to think about SOHCAHTOA as a fraction, so we can make it into a fraction by dividing by 1. It's always legal to divide by 1. What's SOHCAHTOA for tangent? Opposite over adjacent. So I need a triangle that has a 1 and a 1 without the hypotenuse. So that's the 45, 45, 90. So our answer must be 45, which we said goes into 184 times. One more. Let's try inverse sine of 1. Like the last one, we can make it into a fraction, 1 over 1. What's SOHCAHTOA for sine? Opposite over hypotenuse. So we need an opposite of 1. That could be either triangle. They both have 1s. We need a hypotenuse of 1. So which triangle has a hypotenuse of 1? Neither one of them. So that means this doesn't work. So if our answer is not in a triangle, where's our answer? In this circle. In this circle, what part of the point is sine? The second part. It's cosine comma sine. Sine is 1. So the second value of the point should be 1, which means the first value needs to be 0. And where do we find the point 0, 1? At 90. We have the point that is over 0, up 1. So our answer is 90, which goes into 180 how many times? 2. So 90 is pi over 2. Okay, so we try for a triangle first. But if you end up with a 0, zeros are not in triangles. If you have a negative, we don't have negatives in our triangles. Or if you end up needing a hypotenuse of 1, we don't have a hypotenuse of 1 in our triangles. So in those cases, we would need to go to the circle instead. Questions? Once again, there's a lot of stuff that has to be memorized for this. SOHCAHTOA, unit circle, special triangles, 180 equals pi. So make sure you study that stuff and know that stuff so you can be